Hi there, and thank you for clicking on this video. This is our practice set for operations on polynomials, focusing on adding, subtracting, and multiplying. Division gets its whole own thing. Please like and subscribe if you find this video helpful, drop a comment or a question, and check out the many other videos and playlists that are on the channel. As always, pause the video to work these problems on your own, and then come back to check your work. Right, so I'm going to try to fit all these on one slide. I don't think this will be too much of a problem. I'm kind of thinking the next one might get a little bit cozy on the screen. So rather than write out a whole bunch of different polynomials to add, subtract, and multiply, what I decided to do was just give you two polynomials, and we're just going to practice all the operations on those two polynomials. So we're going to start with f plus g. And what I consider an optional step here is if you want to, you can write the problem down with the parentheses. And all that is, if you recall from the lesson, these are cosmetic. It just splits the two polynomials up so you can see, this was polynomial f and this was polynomial g. They don't do anything. If you would prefer, you can just simply write it like so. Okay, and now we're combining like terms. So we have 2x plus x is 3x, and 3 minus 4 is -1 or -1. So there we go. First one, yay. Now, for the next two, it is not cosmetic, at least not the second one. So we have 2x plus 3 minus x minus 4. And in this case, I actually do recommend the separate step. Remember that we are going to add the opposite or distribute the subtraction, however you would like to think about it. In my head, I usually think of distributing the subtraction, but I have found that a lot of my students, that way of phrasing it does not often mean a lot. So they like to think of it as, I have a -1 and I'm going to distribute the multiplication by the -1. Or you can just say, hey, I'm going to add whatever the opposite is. So I'm going to add the opposite of positive x is negative x. I'm going to add the opposite of -4 is positive 4. And then we just combine like terms. So 2x plus negative x is just x or 1x. And 3 plus 4 is 7. Right. Now we're going to do g minus f, and now I'm kind of off from the way it's printed above. So what this is this is switching the order of subtraction, and it's kind of getting at is subtraction commutative. So I know like if I add like two things together that I get the same thing no matter how I add them. So 1 plus 2 and 2 plus 1, that's the same thing. But the same thing does not hold for subtraction. And so what this is driving at is kind of making you do that out, but also to see if you spot like any relationships or patterns with the subtraction. So removing the parentheses here, we're gonna have minus 2x and minus 3. And now this time we have x minus 2x, which is negative x or -1x, and then -4 minus 3, which is -7 or -7. And what I hope that you notice is that you had the positives and now they're negatives. And so you actually have the opposite. You have the opposite there. All right, and the last one is multiplication. So we are going to be doing 2x plus 3 times x minus 4, and we're going to set that up with our area model. So 2x plus 3 and x minus 4. So this is 2x squared plus 3x minus 8x minus 12. And of course, our like terms land on the diagonal, which is really nice. And we get 2x squared minus 5x minus 12 for our multiplication there. All right, let's go take a look at the next one. Now, this one is probably going to get really cozy. So these are much bigger polynomials. So I'm going to try to tweak how I lay them out. The last one I just kind of went straight across, but these are longer polynomials, so we're going to have an issue with that. All right, so first one is adding them. So when I go to add them, I got my x squared minus 3x minus 5. And I'm going to add to that negative 2x squared plus 4x minus 1. And of course, those are the parentheses that are cosmetic. And so I'm just going to go ahead and remove them, and you are welcome to remove them in your initial rewrite. We have x squared plus negative 2x squared, which is going to give us negative x squared or negative 1x squared. We have negative 3x plus 4x, so that would be positive x or positive 1x. And then I have a negative 5 minus 1 or negative 5 plus negative 1, which is negative 6. So there we go on our first one. On our second one, we have x squared minus 3x minus 5, and we are going to subtract from that negative 2x squared plus 4x minus 1. And in this case, the second set of parentheses is not cosmetic. It is telling us what we need to have the opposite of. So essentially, that subtraction is going to flip the sign of everything in the second set of parentheses. And so we have x squared minus 3x minus 5. Now, to subtract a negative would mean to add. So we'll have plus 2x squared minus 4x plus 1. So we're flipping that sign there. X squared plus 2x squared is 3x squared. Negative 3x minus 4x is negative 7x. And negative 5 plus 1 is negative 4. Next one, we're going to switch the order. So negative 2x squared plus 4x minus 1 minus x squared minus 3x minus 5. And now we'll move those parentheses. So we're going to be subtracting x squared. Subtracting a negative 3x would be the same as adding 3x, and subtracting a negative 5 would be the same as adding 5. So essentially that subtraction ends up flipping the sign of everything in the second group. I just don't want that to be something that you're trying to remember to do. You want to remember why it works. So if you need to go back and just see that refresher lesson, the beginning of the lesson where I talk about subtraction is adding the opposite, and I use the example 7 minus 5 as a way to illustrate that. All right, so what do we got going on? We have negative 2x squared minus x squared, which will give us negative 3x squared. We have 4x plus 3x is 7x. And we have negative 1 plus 5, which is positive 4. And note how these are connected, okay? So we have 3x squared and then negative 3x squared, negative 7x and positive 7x, and negative 4 and positive 4. So you might be wondering, will that happen all the time? Yes, it will happen all the time. And I think I could probably illustrate that pretty well, like on a number line. You could just see how that works, or you can do it with like a. I think you can do it just like variables, or like a minus b equals negative b minus a. But we're not going to do it right now. All right, so let's look at that last one. If I can. Yep. So we are going to be doing x squared minus 3x minus 5 and multiplying it by negative 2x squared plus 4x minus 1. So it's going to be a decent size area. I'm going to leave myself plenty of spaces. It's going to be a 3 by 3. You can see them infinitely huge, although you won't, but you can see them pretty big in theory. All right, so there's my base, x squared minus 3x minus 5, and here's my height, negative 2x squared, 4x, and negative 1. And here we go. Negative 2x squared times x squared is negative 2x to the fourth. Negative 2 times negative 3 is positive 6. And then x squared times x is x to the third. And then another negative times a negative will give me a positive. This time it'll be a 10, and we'll have a 10x squared. 4x times x squared is 4x to the third. 4x times negative 3x is negative 12x squared. And 4x times negative 5 is negative 20x. X squared times negative 1 is negative 1x squared, or just negative x squared. Negative 1 times negative 3 is positive 3, so we'll have positive 3x there. And negative 1 times negative 5 is positive 5. And wow, I love this. My like terms are on the diagonal there. Okay, which makes it much nicer for adding. And what is my final answer here? So we have negative 2x to the fourth plus 10x to the third. Oh, the best way to do this is going to be what? Negative 3x squared. Okay, minus 17x plus 5. Hopefully I didn't make a careless mistake in there. Drop a comment if I did. Drop a comment to engage, man. Like, lady, you're. I should have numbered this. Number 8. There we go. You're making mistakes, but there we go. Okay, moving on to number 9. So this one is intentionally set up to be just a little bit different, keep you on your toes. It's still the same kind of problem. Just when you notice that you have terms missing, you know that you're not going to have that really convenient, all of my like terms are like all together, unless you want to put in those missing zeros. All right. So here we have 3x to the third times x squared. So that'll be 3x to the fifth. Negative 4x squared times x squared is negative 4x to the fourth. And then we have a 2x squared in that right-hand box there. 2 times 3 is 6, and this will be another x to the fourth. Negative 4 times 2 is negative 8, and that'll be an x to the third. And then 2x times 2 is 4x. And now we don't have that nice, like on the diagonals, our x to the fourths are, but this diagonal right here does not work. And we don't have a constant. Because we didn't have anywhere in there a constant times a constant. So let's take a look at what we got. We've got the x to the fourth, and then we have the x to the third, and the x squared are on their own. So we have 3x to the fifth plus 2x to the fourth minus, sorry, what did I try to do? I tried to combine, even though I just said, like, what do we have? Minus 8x to the third plus 2x squared plus 4x. And there's your answer. Ta-da! Beautiful. In all its glory. Okay. Now, this last one. This one I wrote on the problem slide, like this is definitely a challenge problem. So this is really pushing into division. So this is where you have something and you know what the area is, okay? And maybe you know what one of the dimensions is, and you are asked to find the other one. Well, you would ask yourself, well, 6 times what gives me 30? Or you would do 30 divided by 6 and you would get it that way. Now, 6 times what gives me 30? That you can probably do in your head. But what if those things were, I don't know, a whole slew of polynomials instead? Now what would you do? Okay, so I'm going to work it out for you. Just keep in mind, this was intended to be a challenge problem. It was intended to push you. So if you take a look at your page, it should not be blank. Okay, you should have tried to do something with it. And then what you're going to gauge right now is how far did you get in the right direction. All right. And the division video is going to be a whole lesson on this. This is just kind of testing the waters. Like, what can we do with it? So what I'm going to do here, because we haven't established any rules for anything, is I'm going to draw like a really big rectangle. Okay. And I know that one of the factors is x plus 3. So I've got the x plus 3. What I'm looking for is the other piece, okay? If you go back to this one as the analogy. Now, there is a way to know how many columns you should have, but we don't know what that rule is yet. Like, we are just exploring. Now, probably it's not that big, okay? Because if you take this times this and it's like really this big, you're gonna end up something with bigger there, okay? Now, this, we need to fill that area, or at least some of that area. Remember, we might have some extra boxes, okay? Because we don't know how many to draw, so we're just like drawing some there. But we can figure that there is a rectangle here that we would fill up with that. All right. And the trick is that this represents them when they're already combined. And so what we don't know is what would have been on those diagonals. But what we can be pretty sure of is that this right here would be the x to the third, okay? Because in all of the ones that we've done, the highest exponent was by itself, and it was sitting up in that upper left corner. So that's probably the x to the third, okay? Now, from there, we can figure this out because we know that the x times whatever is here should give us whatever's in that box. And so that leads us to thinking, all right, well, that's x squared. X times x squared would give me x to the third. And from here, I can figure out what goes in this box because I know that this box is base times height. So it's 3 times x squared. So that has to be 3x squared. Now, just like follow me here. Remember how our like terms are on the diagonal? Okay, so if this is an x squared, this also has to be an x squared. And when I go to add up all my areas, I need them to add up to 5x squared, okay? Because remember, this is the simplified version. It's where all of them were all put together. We added everything up, and it was great. But now we gotta like kind of break them up here. So 3x squared, that would make this 2x squared, because 3x squared plus 2x squared would give me the 5x squared. And now I can actually repeat the process. So I know the height of the square, I know the area, I can figure out what that is. So x times what would give me that 2x squared? Well, that would be 2x. And you can kind of see that we're going to fall into a pattern here. So this area down here must be 3 times 2x. So that's got to be 6x. But remember, the diagonal, that little rule about them being on the diagonals, if this is an x, this has to also be an x, and they would have to add up to the 7x, which means this must be 1x. And now I can do this again. So I've got the area, I have the height, what is the width? So x times what would give me 1x, that's going to be 1. And then now that I have that, I could find this area. 1 times 3 is 3. And that actually matches what I know I want to have. So what we did, if you look at this, okay, look at what's in the box. X to the third plus 5x squared plus 7x plus 3. X to the third plus 5x squared plus 7x plus 3. Now, it turns out we don't need all of that. But I don't think I can erase it. Yeah, if I do that, I end up erasing all of that. Well, that's just, okay. So we didn't know how many boxes we needed. We just ended up with some leftover boxes there. But now take a look at what we got. So we have the base, we have the height, and we have the area. And essentially what we did was a division problem. We took what we knew the area was, we divided it by what we knew the height was, and now we've got the other dimension, which is x squared plus 2x plus 1. So what we did there was we did x to the third plus 5x squared plus 7x plus 3 divided by x plus 3, and it gave us the other dimension, and you can see the numerical equivalent there. We did 30 divided by 6, and that gave us the other dimension, which is 5. Here we have the area divided by the height, and it gives us the other dimension. So there you go. Now, again, that was intended to be a challenge problem. I would never toss that out expecting a student, like having my expectation be that my class is going to like get it all the way to the end. But I am often curious if anyone can get it, or how close you can come, or what kinds of questions you ask from seeing it done out. So do you have like questions? Does a student come back in and say, okay, I think I got this set up? And then like we can have a conversation about how they're thinking and how they're seeing it and what they're perceiving, and that can lead into an even better lesson. So don't shy away from challenge problems. Like tackle them, see what you can do, see where was my thinking okay, where did my thinking go off, did I make it all the way, part way? This one has all positive numbers, which makes the arithmetic a little bit easier. And of course we can mess this up. What if you have like things with zeros in them? So we can do some like pretty trippy stuff. But if you made any progress with that at all, and feel like, okay, I kind of followed what she did there, not too bad, give yourself a star for today. That would be awesome. All right. So please don't forget to like and subscribe if you found this video helpful. Drop a comment or a question. Let me know what you'd like to see. I know at least the year that I'm recording this, I don't know. I mean, once you put stuff out there, it's up there for a long time. But at the moment, a lot of schools have just started. I've been in school for about a month. Schools up north are just going back. But let me know if there's something that you'd like to see. If it's already on the channel, I'll help you find it. If it's not, I'll see what I can do about making a help video for you. And please check out the many other videos and playlists on the channel. We have lots of resources for multiple choice questions, Desmos, algebra tiles, algebra 1, a smattering of geometry, but I'm game for doing some geometry if that's what we need to see. But go ahead and check it out, and I hope to see you in a future video.